Okay, so now we're going to discuss combinations. So just as a quick review, we had permutations, which were NPR. And the formula for NPR was n factorial over n minus r factorial. So now what we're going to have is we're going to have a new formula. It's going to be NCR instead of NPR. And that's going to be n factorial over r factorial n minus r factorial. So n factorial over n minus r factorial, n factorial over r factorial, n minus r factorial. So for example, if we had 6 choose 2, that would be 6 factorial over 2 factorial times 4 minus 2 factorial, which would be 6 factorial over 4 factorial, 2 factorial. So make sure you could find it on your calculator. So calculate these guys. So what is 10 choose 3, 10 pick 3, 14 choose 14, 10 choose 7. So 10 choose 3 is, and everyone's calculator is going to be different. Some buttons just have it like that, others it's hidden by probability. So mine is like this, and it says 10 choose 3 on it. So that's 120. 10 pick 3 would be 720. 14 choose 14 would actually be, if you plug it in, you would find out that it's 1. And the reason it's 1, I'm just going to point that out actually. So 14 choose 14 is 14 factorial over 14 factorial on 14 minus 14 factorial, which is 14 factorial on 14 factorial 0 factorial. And as you may or may not recall, 0 factorial is just equal to 1, and then 14 factorial over 14 factorial is also 1. And 10 choose 7, oh, I forgot to say what it is. So the wording we use, NCR, so if I say, the way I say this is 10 choose 3. And that's the wording I'm going to use always. Right, so that would be 7 choose 2, 8 pick 3, 10 choose 1, and something along those lines. Okay, let's do an example. You have 7 friends. Three to Hawaii. How many different groups can be bought? So brought, taken, be taken all. Brought, I don't know, taken. So let's say we were going to pick the 3 friends in order. If we were going to pick the 3 friends in order, then we would have, that would just be 7 pick 3. So if we had 3 friends and we were going to bring them in order, it's 7, we're picking 3 of them, and that would give us 210. But let's say our friends were, A, B, C, D, E, F, G. So one of the groups we could bring is A, B, C. So we could bring our friends A, our friend B, and our friend C. But the order that we bring them doesn't really matter here. So ABC is the same thing as ACB, which is the same as BAC, which is the same as BCA, which is the same as CAB, which is the same as CBA. So all six of these are actually just the same group. And any group we bring, any group of 3 that we choose will have 6 variations that look the same. So of the 210, we could divide it by 6, or we could divide it, or in other words, 3 factorial. That's a number of ways this could be done, to figure out how many different groups there are. And if we have 7 pick 3 over 3 factorial, that's going to be the same thing as 7 factorial over 7 minus 3 factorial all over 3 factorial, which is 7 factorial over 4 factorial all over 3 factorial. And if you do the algebra, this becomes, I'm going to go through this, over 4 factorial, 3 factorial, which is just 7 choose 3. I've gone through that relatively quickly. You could go through it slowly and convince yourself that it's true. But the point is that if order does not matter, then we're going to use combinations. So permutations are when order matters. Combinations is when we're picking groups, and the order just doesn't matter. So 10 people in a race, and 4 random people get a participation trophy. Yay, we're all winners. Well, I guess 4 of them are winners. How many different groups can be chosen? So that was a long question with a pretty straightforward answer. We have 10 objects and we want to give out 4 of them, but we don't care about the order we're giving it out because everyone's getting the same participation trophy. So that's just going to be 10 choose 4, which is 210. Okay. So 10 people in a race still. 10 people in a race. Winner gets gold. Second place gets silver. Third gets, you know, they always give bronze, but it really should be copper. If you look at the periodic table, I'm going to say copper. How many different results are possible here? So there's 10 people in the race. The winner gets gold. The second place gets silver. Third gets copper. How many different results? And the answer is, of course, 10 choose 3. Nope, it's not. I lied, actually. It is not 10 choose 3. Why is it not 10 choose 3? It's not 10 choose 3 because here the order matters, right? If we had 3 people, right? So if we have, you know, person A, person B, and person C, and if we give this person gold, silver, and copper, that's one thing. But if we say, yeah, I'm going to give you silver and you gold instead, that makes a difference. The order, so in this case, the order matters. So since the order matters in this case, the answer would actually be 10 pick 3, which on the other page we already got was 720. Order matters permutation. Order does not matter a combination.